Thank you everyone for joining. Appreciate the attention. So I always like to start my talks by giving a high-level TLDR, kind of set the scene, set the expectations, right? This, unlike Sebastian's awesome talk, always enjoy Sebastian's talks. There's no live coding in this one. This is going to be a high-level architecture sort of overview pitch. We're going to look at API gateways in particular. Now, they've undergone a series of evolutions over the past 10, 20 years, driven primarily by architecture and technology. Now, I think my pitch, and I've learned from many other people, it's not just me, but adopting microservices, Kubernetes, cloud containers, all that good things, they change the workflow. And therefore, it's not just architecture and technology driving API gateways now, it's the workflow too. And the main message for everyone out there, whatever language you're using, but definitely in the world of Java, where you've got Spring Cloud Gateway, Zool, other great technologies, choose your API gateway intentionally if you're moving to the cloud, moving to Kubernetes. I've done it myself. I've seen other people do it. They just roll in with what they've got, on premise or some other kind of deployment, going to the cloud, going to Kubernetes, they lift and they shift their gateway. Now, I'm going to say that's not always the right thing to do. So bear with me. We'll do a history tour, and then I'll do some highlights on, I think, challenges within API gateways and what you can do, what you can think about in particular when you're doing this migration into the cloud, really going, Kubernetes native, cloud native. A kind introduction already, thank you very much. Most of the places, GitHub, Twitter, LinkedIn, at Daniel Bryant UK. I'm typically based in the UK. Today I am in very sunny Boston. It's actually quite rainy here in the United States, but typically I'm just based outside of London. I work as head of DevRel Ambassador Labs. My background is Java development, JavaScript development, bit of Go, did some operations work, bit platform engineering, built out platforms, Mesos, Kubernetes, written a couple of books, my buddies as well, Abraham and Perez, Jim, and Matthew. The Mastering API Architecture is literally being published as we speak. The Continuous Delivery in Java book has been out a couple of years now. So I love learning. I love everything from the dev side. I love everything from the ops side. And today we're going to marry the two dev and ops with a focus on API gateways. I'm going to be talking a bunch about the edge, and the edge means many things to many people. But when I'm talking about the edge, I'm talking about the boundary between your data center and your users, the proxy, the load balancer, the API gateway, that kind of edge. We're not going to look at, say, CDNs. We're not going to look at IoT stuff that much. I'm talking about the data center edge, typically where an API gateway is deployed. I mentioned in the TLDR, I think the edge technologies have been driven a lot by application architecture and technology over the years. So let's have a quick look at that. Let's go back even before I was developing professionally, right? In 1995. I'm old, but not that old. I was still in college at the time, still at school, but I was playing around with all the tech, right? Java emerged, obviously, big deal. Typical architecture, very simple. Web browser, applets, J2E backend, database. Excuse the poor resolution on this image, but I thought it fitted, right? 1990s, it's kind of like low res. The internet was just becoming a thing back in the day. Hardware load balancers were all the rage back then. It was mainly operating at the layer 3 of the OSI network layer, so quite low level, TCP IP, that kind of thing, routing traffic into the back end. Your application was responsible for all the routing, all the reliability, security, all that good stuff. There was hardware deployed in front of your VMs or your bare metal that you're running your Java apps on. Fast forward to 2000s, I was working, and I just finished university. I was doing some consulting at the time and doing some work in the UK government in particular. Big J2EE deployments, big SOA things, ESBs were all the rage, right? Message queues, all this good stuff. Similar application architecture, but we started to see those kind of coarse-grained services pop up. This is when you see the emergence of software-based load balancers, in particular, HA proxy, Nginx. I'm sure we all know and love both these techs as well. And these were very much the same as hardware load balancers, but they were more malleable. You could configure them in software much easier. Nginx directives, Nginx config, HA proxy config, cheaper, easier to scale, not as performant as hardware, but the flexibility and the cost savings were already there with software load balancers. Fast forward to 2005, Web 2.0. I remember this is all the rage at the beginning of my career. E-commerce was popping up, right? The second coming after the dot-com crash. Ajax was super popular, believe it or not. This is proper old school now compared to things like React apps and single-page applications we have these days. But Ajax, asynchronous JavaScript and XML was just the thing. Around this time, some technology popped up called application delivery controllers. Now, not everyone's heard of this. Kind of a marketing term. I know F5, Nginx, Citrix used it a lot, but even if you don't recognize the name, you'll recognize the functionality. The ADCs were typically responsible for things like TLS, SSL offload, taking it away from the applications. You have multiple endpoints now. You're dynamically updating lots of data. You're making these asynchronous calls. You're building HTML pages dynamically, whereas before that it was like request response, request response. Now there's a one request response and lots of little request responses too. Caching, all the ilities, right? Security, reliability, maintainability, all that good stuff. Compression load balancing was put in this ADC. Now, for you, it may have been a load balancer. You may have put it in part of it into Nginx, that kind of stuff as well. But there was this notion of like offloading from the applications a lot of the ilities. 2010 times, APIs were emerging. 2005, I did a lot of work on Google Maps back then, some Java apps with DWR, and actually, for folks remember that, dynamic web promoting, and other interesting JavaScript frameworks. This is when we saw the first generation of API gateways aimed not only at ops folks, but now at API developers. Me as a developer getting involved with the API gateway for the first time. Super interesting, right? We're exposing APIs to the broader ecosystem publicly, trying to monetize them. There was a lot more focus on the layer 7 in the OSI model now. So layer 7, HTTP, we were routing based on headers. We were doing like smart rate limiting based on headers, based on IDs of people logged in, all that good stuff. Definitely a move up the stack from layer 3 to layer 7, and me as a developer getting involved with the configuration. Developer portals are emerging, analytics, monetization, Scale, Kong, Apogee were kind of popping around this time as well. Lots of interesting technologies. 2015 time, I was doing a lot of work on microservices this time. In particular, a lot of successful companies I was consulting with were moving from a monolith to microservices. Kind of Twitter is the architect of this. At the time, right, we saw the Twitter fail whale, their famous monolith Ruby on Rails app wouldn't scale with the number of, when there was a soccer match, football match, everyone bundled onto Twitter, and Twitter simply didn't scale. So Twitter broke out, their monolith into these mini services. I was working with companies using things like Ruby on Rails, migrating to Java, smaller Ruby apps, these kind of things. The monolith was still fronting all of the applications. It was responsible for the routing, the rate limiting, the security. Often the ADC was kind of doing the SSL offload, and you were doing some like basic sort of layer 3 routing, but the actual monolith itself was still responsible for all the routing, the API gateway-like functionality. Second generation of API gateways emerged, sort of pulling up a lot of the cross-functional concerns. Auth, rate limiting, caching, all this kind of stuff, pulling it up from the monolith that was kind of breaking down into a mini-lith now, right? Many microservices surrounding it. Again, a whole bunch of companies I was working with in Germany, in London, in Poland, I was working in there as well. They were doing a lot of these migrations towards what we're now calling microservices, mini services, all that good stuff. But they were pulling up the cross-functional concerns from the app to this API gateway second gen. And again, I, as a developer, was using the gateways quite a lot, typically REST APIs. You control the gateways via REST APIs. You were saying, expose this route. Here's the rate limiting I want. Here's the auth I want. It was very imperative the way you configured the gateway. All the things I mentioned before, centralizing cross-cutting concerns was actually a good thing, right? It means we could bring in other languages into the stack. Again, I was doing a lot of work at this time with Ruby, Go, JavaScript, Node, Java, and the API gateway centralized a lot of the cross-functional concerns, so I didn't have to worry about implementing all the different things in different languages, which at the time was awesome. So let's look at cloud native apps now. We're all in on microservices, right? This is a thing like modularization. We had sort of like David Parnas's classic 1970s programming modularization. We had the SOA, and now we've got microservices. If you're doing microservices correctly, and I do a massive hat tip to folks like Sam Newman, Rebecca Parsons, Sarah Wells, James Lewis, Fred George, all the people that have come before me. If you're doing microservices well, you can build and release them independently. This is great for scaling your dev efforts, scaling the applications themselves, but it does put the onus on us as developers to configure the individual services and make sure they all work together, right? On the technology side, As I did a lot of work with Mesos, a lot of work with AWS, various clouds, and then Kubernetes became a thing. If you're working in any size, any reasonable size org, you're going to have a mix of all these techs. You can have Kubernetes, VMs, maybe some function as a service. You're going to be using different protocols because you can use different languages, different protocols, and different services. And you're going to have all different requirements for the cross-functional concerns for often each of the services, right? And I see this a lot in big organizations that have multiple authentication services. Not always a good thing, but this is just the way it is, right? Multiple authentication services, and we as developers need to be able to choose, I want Auth here, Auth0 here, the on-premise version of Auth here. We as developers operating these various different APIs and services need to be able to configure these things. So let's take a pause. What do we need from a cloud native API gateway? We've seen the move from hardware to software. We've seen the move from layer 3, the sort of low level routing, to layer 7 where we're routing based on headers, IDs, that kind of thing. We need this API gateway management functionality as in a cloud native gateway, right? Authentication, dev portal, metrics, all that good stuff. We need ADC like reliability, security, extensibility, right? And we also need this real-time service discovery. In particular, love some Kubernetes, right? But it's very dynamic. That's its strength and also its weakness in that services can come up, get shut down, can disappear. So our gateway needs to be very dynamic in its routing choices. The key thing I teased at the beginning is microservices lead to an even bigger change, right? There's this notion of you build it, you run it. And as a sort of previous Java developer, full stack developer, the danger is, I like owning what I code from idea to production, but it feels like I'm a one-person band sometimes, right? I've got to know JavaScript, Java, Terraform, Kubernetes. There is a lot of stuff to learn, right? And I think really we have to provide the abstractions at the ops, at the platform level for us developers to do our jobs without getting overloaded with all these different things going on. I like the idea of owning a code, but we've got to think about the abstractions on how we interact with the platform in particular. There's this notion, I think it was started by the Netflix folks, a bunch of other folks jumped on it too, of full cycle development. It's got to be backed by a operations, a platform team. Now, this can be primarily, using the AWS or GCP or Azure services. You may have an in-house platform team that offers some kind of SDKs, tooling, that kind of stuff, but they offer the ways to interact with the platform, the gateway, the CI pipelines, all this good stuff. And then we as developers are responsible for going as fast as we can, typically, and as safe as we can, right? Depending on the requirements of your business. Speed and safety, two really important things, but we can go in our loops. We're responsible for designing all the way through to deploying and iterating through. Now, if you're not familiar with this concept, fantastic book by a couple of buddies of mine, Matthew Skelton and Manuel Pace. Got to mention them. I do in every presentation. This is an amazing book, but it talks a lot about we're encouraged as developers to go fast, to go safe. We're doing this full cycle development. We're responsible from designing, deploying, releasing, getting feedback, but we've got to have the platform. We've got to have the abstractions that help us as developers. We can't do everything, right? We can't be designing the chips as well as writing the web apps. It's simply not possible. So it's a change in workflow. How we interact with the platform team as developers is a big change in the workflow now. And I think that the pitch I'm kind of coming up with now, my team are coming up with, is the evolution of the edge of API gateways in the future is going to be driven by application architecture, technology, and workflow, right? This workflow is changing, smaller units of code being deployed is creating a big change in our industry. And things like function as a service are accelerating it even more as well. So two challenges I see in particular with Kubernetes and the edge. I'm doing a lot of work in the Kubernetes space, but this is probably, pick your framework, right? Pick your platform. You'll probably recognize some things here, but I'm doing a lot of work in the Kubernetes space. So I wanted to share some lessons I've learned over the past few years. The biggest challenge is scaling edge management if you're migrating to a monolith, to microservices. In the monolith world, as a developer, we're typically controlling things like rate limiting, circuit breaking, tracing, all within a library. If you're, again, I'm a big Spring user, right? If you're using the Spring framework, Spring Cloud gives you all this functionality. You can put it all in your app, but many other frameworks do the same thing. Often you'll have like an API gateway, load balancer, WAF, CDN, all this kind of stuff, owned by an ops team. Now, most of the stuff we can control as developers, in the actual code, but if we want to change the API gateway, we have to raise those famous tickets, right? Jira, pick your poison, whatever framework you or whatever tool you want to use. But this all takes time, right? The ops team have got to action the tickets, give you feedback, some loops happen there as you kind of iterate. You want to expose new routes, new protocols. This can be really time consuming, particularly as we've lifted up a lot of the functionality into the API gateway now, a lot of the cross-cutting concerns into the API gateway. As we get more and more services, I can't be raising tickets all the time. It slows me down as a developer, and it's in some ways not fair on the ops team, right? They're just constantly reacting to tickets. Ideally, we want to focus on self-service. We want to be able to do our thing as developers without constantly bugging the ops team. The second challenge I see is supporting diverse edge requirements. As we've got microservices, we can use different frameworks, a bit of Kotlin here, a bit of Scala here, Go here. We might also choose different API technologies, different transport technologies. Everyone loves a bit of JSON over HTTP. I see a lot of gRPC, gRPC web at the moment, WebSockets, HTTP3, all this kind of good stuff. But I also want to mix and match different cross-functional concerns with each of those services I'm writing, right? Like I may want really strong auth on my checkout service, on my cart service, but I don't want any auth at all on my newsletter sign-up service. And I, as a developer, want to say, here's what I want from each of my services. So here's 3 strategies I've seen working with customers, pre sort of Ambassador Labs even, but definitely at Ambassador Labs, working with a lot of very interesting folks migrating from huge on-premise deployments or huge cloud deployments even to Kubernetes. And I've seen broadly 3 buckets of how folks are managing this. They've often deployed an additional in-cluster Kubernetes API gateway, as well as existing API gateway. We'll cover that more in a minute. We'll go into all these strategies in more detail. Sometimes they extend the existing API gateway, particularly if they've built their own gateway on Spring Cloud, or I see a lot on Zool, the old school like a Netflix technology, but people have invested a lot in their gateway. They're trying to extend it using Groovy scripts, that kind of stuff. Some folks have built things on Caddy in the Go world, so they extend their existing API gateway. And the new, the ultimate kind of greenfield strategy is deploying an in-cluster edge stack Kubernetes API gateway. Great for greenfield, obviously very challenging for migrations because you've got the existing world you've got to keep running, right? Let's dive into each of these now and look at some of the strengths and weaknesses. So it's going to be a whistle-stop tour. I've shared a link in the previous slide actually with a article I've written, the team and I put together, that goes into more detail if you want to know more detail. But this first strategy is simply deploying a new API gateway into your Kubernetes cluster and routing, passing through the existing the target traffic from the existing API gateway through to the new API gateway. So that old API gateway still does the routing for all the existing services, but anything new gets passed through into the new world, if you like. Nice and easy. Developers can manage this. Ops teams can set up guardrails. For advantages, it's minimal change to the core edge infrastructure. You can leave your existing WAF, your existing API gateway in place. Incremental migration is easy. You're kind of growing a new world on the side of your old world, right? And with that being an advantage with incremental migration, the obvious trade-off is that you're working with multiple components. In particular, I had a couple of gnarly customer use cases where they couldn't get authentication working properly in the API gateway in Kubernetes. And it turns out the existing API gateway was stripping some of the headers. Even though it was routing the traffic through, it was stripping out certain headers for security reasons. Makes sense at the time, didn't make sense in the new world of a Kubernetes API gateway. So 2 components, bit of conflict there. That was one of our challenges. And it can also be tricky to expose all the functionality you want within the new Kubernetes world, right? Because you've always got this other API gateway sitting on top that does auth or does other things. So it can be a bit of you need strong collaboration between dev and ops if you're going to make this move. Extending your existing API gateway, this is literally sort of putting a new solution in that synchronizes your Kubernetes services with your existing API gateway. I saw a lot of people doing this, particularly 2 years ago when I was working on projects. I can't name actually some of the names, but they're quite big names you would have heard of. They've invested in their own gateway. A lot of them are building it on Go and quite a few on Java too, but they didn't want to throw away, as I saw it, all the existing work on the API gateway. So as they adopted Kubernetes, they just bolted on some plugins into their existing API gateway that watched for changes in services in Kubernetes and updated the routing table within their API gateway. basically synchronizing API endpoints in the new world with this sort of with the router that's based in the existing stack outside of the cluster. People liked it because it's easy to reuse the gateway, right? They'd already tried and trusted this gateway, been running in prod for a couple of years. Is one customer I'm thinking of. They didn't want to go away from that. They wanted to extend that gateway rather than do a whole new thing, right? Or deploy another gateway in the cluster. They had a bunch of integrations with existing on-premise infrastructure. They had some custom WAFs and load balancers and auths, so they were very reluctant to move away from that kind of thing. The tricky thing was there was conflict sometimes, like trying to synchronize all the Kubernetes services with your existing services, particularly when they're migrating. They had a hard time getting those synchronizations working sometimes. There wasn't a single source of truth. The Kubernetes cluster had one source of truth for services, for APIs, and the old world had another source. And as they were trying to mash them together in the gateway, it got a bit confused sometimes. So there was some gnarly debugging we were doing there. And it was also quite tricky for the developers for us to specify some of the properties we wanted. We were using Kubernetes annotations, Kubernetes CRDs to define our ingress objects, but it didn't always work. Like not every thing we wanted to do was recognized by the old gateway. So that created some challenges. The greenfield solution, right, is deploying a Kubernetes native API gateway. There's many choices out there. Obviously, in Bast Labs, we work on emissary ingress. We're working on the new Envoy gateway project with the Tetrate folks, with Fidelity, with VMware. So emissary ingress and Project Contour, both Envoy proxy powered technologies. We're coming together and doing a lot of work in this space. So have a Google for emissary ingress, have a Google for Envoy gateway if you want to know more there. But there's a lot of work going on in the cloud native world, in the CNCF, the Cloud Native Computing Foundation, and we're actively contributing at Ambassador Labs. And this is nice if you're greenfield. You literally put everything in Kubernetes, single source of truth, very GitOps friendly, right? I think I've actually got that on the next slide. If I just move on, deployed in cluster. This is the very Kubernetes native way of doing things. You can specify mappings, routes, these kind of things. You can specify rate limiting or your auth, all in Kubernetes YAML. So you're just committing that into your repo as you would any kind of Kubernetes config, and your CI/CD process, your GitOps process can be syncing that config with the cluster, nice and easy. You can even route to external services from your new gateway, right? That's quite a common use case. You can just route, long as the service is network addressable, you can route from Kubernetes out to a service, or you can use something like a service mesh. I did a whole bunch of work a year or two ago with Linkerd on multi-cluster service mesh. So check out my videos online if you want to know about that more. Um, the cons are obvious, right? It's a big architectural shift. If you've got lots of stuff running in prod, you're not going to suddenly overnight go boom, move everything across to Kubernetes, including your gateway. So this is a big challenge. It can be your end state you want to aim for, but it's going to be an incremental migration to get there. I've also seen, as much as I'm a massive proponent of Envoy. It's an amazing technology, and I think it's the future, right? I'm definitely betting on that in terms of Ambassador Labs is betting on it. I'm betting on it personally as well. Envoy Gateway is amazing. Envoy Proxy is amazing, but it is a big shift from existing hardware technologies, even other software technologies. So your team has to learn about this new tech, right? So that is not a cost to be underestimated. Again, I think it's the right thing to do. Envoy Proxy is a very much cloud native proxy, but again, just requires a bit of learning. So do recognize that in any kind of migration you're doing. I think we're pretty much coming up to time. Left a bit of time for questions there. What I want to get you to think about is there's been this evolution primarily around architecture and technology, hardware to software. We moved from like layer 3, layer 4 to layer 7 in terms of dealing with TCP/IP versus dealing with HTTP, routes, using headers, these kind of things. And there's a big shift as we've gone towards microservices to look at decentralized config, right? We're no longer all crowding around one monolith. We've got many services going on. How do we as developers deploy those services, configure those services, make sure they work together well? This is a big challenge, a big change in workflow in addition to the change in tech and architecture that we've seen in the past. Two things to really think about: scaling that edge management, particularly as you get more and more microservices. When you hit, say, pick a number, 10, it's really hard to be modifying API gateways through tickets. If you work in a big org, you totally recognize this, right? You're constantly raising tickets, ops come back with a question, you answer the question, bit of feedback. Like that's not going to scale as you want to be rapidly rolling out all these microservices. And the beauty of microservices, if they've done right, is you can go faster and you can work independently. But you've got to have all parts of your platform, including the API gateway, supporting that. Do you think, as you probably adopt more technologies, microservices, you can use different languages, you can use different protocols. Again, I see a lot of gRPC at the moment, HTTP3 becoming increasingly popular. The cross-functional requirements change along with those things. You want different rate limiting, different auth, all this kind of stuff. We need to be able to configure that, ideally in a kind of Kubernetes native or cloud native way, right? Using YAML to say, I want this auth, I want this rate limiting. We want to define that along with the rest of our app properties, rather than using some kind of other tool or creating tickets again to get that configured. And the big message really is, do choose your API gateway if you're moving to the cloud, moving to microservices, moving to Kubernetes. Think about all parts of the platform intentionally. Like it's going to change, but the API gateway, I've done a lot of work in this space at the moment, so I'm focused there. But I see folks that haven't thought too much about the API gateway as they're moving across. They just lift and shift, and it slows them down or creates problems for them. So if you're doing this migration, it's a perfect chance to think, what are all my communication requirements? What are all, how am I going to be doing routes? How am I going to be updating config? Do my ops team want to set guardrails? Do my developers want to be, every day creating new mappings, these kind of things? Be very intentional with any move towards the cloud, any move towards microservices, and choose your API gateway technology intentionally. I think we're bang on time there, hopefully. A lot of resources there. I've done some podcasts with some amazing people in the community. Alyssa Wilk jumps to mind. I see her on the slide there, talking about how Google implemented HTTP3. And Google, like, we're not all Google, right? But I love learning from folks like Google and what they're dealing with. So Alyssa did a deep dive into HTTP3 and microservices, all that good stuff. And there's a bunch of other resources there that you can look at and learn. And you can always find me on Twitter's at Daniel Bryant UK, GitHub, wherever, the Ambassador Labs, OSS Slack, wherever you want to get in touch with me, please reach out. And I really appreciate your time today. See if we've got any questions.
Thank you, Daniel. It was a really timely mannered speech with great timing, actually. And thank you very much for this information. It was impressive. Let's look at the questions. We actually have one at the moment. Could you recommend some API gateway which is the most used or which you like the most? Also, gateway for GraphQL, as our listener understands,
Sebastian.
Spring Cloud Gateway doesn't work with GraphQL. Yeah.
So in terms of recommending gateways, right, I'm obviously biased. Ambassador Labs, we have Emissary Ingress, which is a CNCF API gateway, and we've built a commercial gateway on top of that. So I'd love folks to check that out and give us feedback. Just Google for Ambassador Edge Stack. Like I said, we're doing a lot of work and with Envoy Gateway as well, a new open source CNCF driven technology. So Google Envoy Gateway if you want to learn more. But there are many other gateways out there. I've mentioned a few as we've gone through. I would recommend thinking about your requirements for your gateway, and then evaluating the gateways that are out there, doing a bit of a search, because every gateway I think has strengths and weaknesses that map to your requirements, your workflows. So think about what you want from an API gateway, think about your skill set, think about your existing tech you've got deployed, and then go out and research what gateways are going to fit best with that. So yeah, I think that's the best answer sort of for choosing an API gateway. All the gateways, like and definitely Emissary Ingress and Master Edge Stack, do support GraphQL. We get that. I didn't actually mention GraphQL that much, but we do get a lot of folks. I'd say more folks using gRPC and gRPC Web, just anecdotally in my experience, but we are seeing folks using GraphQL. And there's some amazing frameworks out there from the Netflix folks. So you can often just sort of, there's a single endpoint with GraphQL, right? Your API gateway just does the pass through effectively of that endpoint. The Netflix folks have got some amazing Java GraphQL technology, as have the Apollo folks. Folks are Googling Apollo gateway. I've seen some people put, say, Emissary Ingress up front for the main cloud gateway, and then use Apollo behind that for doing GraphQL as well. So in terms of Spring Cloud Gateway supporting GraphQL, I'll be honest, I haven't looked at that use case. I've done a bunch of work on Spring Cloud Gateway. There is a few limitations I've even bumped into in the Kubernetes world with Spring Cloud Gateway. Some of the stuff can be overcome with VMware's Tanzu product. Again, it's a commercial product that VMware offers. You'll need to pay money, but they've done some proprietary extensions on top of Spring Cloud Gateway. So the GraphQL problem, if it is, again, I don't know specifically about GraphQL and Spring Cloud Gateway, but if it is an issue, have a look at VMware Tanzu stuff. You will have to pay money, but that can be a way to sometimes overcome the problems, right? And you have to do a trade-off analysis. Do you want to spend the money, or do you want to do it yourself, or whatever? Yeah, I think that's probably the best advice I can offer with the GraphQL.
Mm-hmm. I see. And what you think about, the world has changed a lot, and there are lots of tweets in the internet, and cybersecurity is now actually a trend. And what you think about forcing API gateway to protect us, for example, from DDoS attacks and things like that? Is it actually good use case for API gateway usage? What do you think?
So, the honest answer, I think, is yes. It does depend a little bit on your scale. A lot of our customers, for example, do use rate limiting to prevent denial of services attacks. The ops team configure the gateways to always enforce TLS, to always enforce authentication, OIDC. We integrate with all like Okta, Auth0, that kind of thing. So it's a good place to do a lot of that security. The way I look at the API gateway, it's like the front door to your house, right? You want to make that front door secure. You want to make it lockable. You want to be able to get through it, of course, right? But like that's the first place you want to think about security is your front door, right? And then you also want to do security within your network perimeter. And if folks are interested in this space, googling for or searching for zero trust networking, that's very much popular at the moment. Service mesh is enabling that even more. So you always want to think about security within your network, within your microservice domain as well. But yeah, I think the API gateway is a great place, the great front door, if you like, to be checking things like security. If you're super big or super high scale, you may want to think about some of those security checks being offloaded to third-party services like CDNs, for example. We integrate with Signal Sciences, who operate a web application firewall, a WAF, and a lot of our customers love that because it screens for bots, it screens certain bad things before it even reaches the gateway. Do you know what I mean? It's literally something deployed in front. So depending on your requirements, your size, your appetite for spending money, because these things aren't free, right? Many cloud products, I know all the main cloud gateways offer like shields, or they call them, or kind of CDNs, WAFs, all this kind of thing. So if you're getting DDoSed a lot, like if you're a government or if you're a financial organization, you probably want to invest in like third-party software even before it hits your API gateway to do basic bot detection, DDoS attack prevention, all that kind of good stuff. But many of our customers, particularly the sort of the small medium businesses, use the API gateway to do all of that. And Envoy proxy and technologies built upon it are more than happy at handling an average kind of DDoS and an average kind of like or a typical authentication and TLS requirement.
And one more question I would like to ask for your opinion is about do API gateways get rid of such a pattern like service locator or service registry? Do we actually have cases when we should combine them both?
Yeah, that's an interesting question, and the honest answer is yes. Like depending on your use case, we've done a lot of work with HashiCorp Console in particular, right? So Console being the single source of truth, and you can use Console as a service mesh as well. So you can update the Console registry, the key value store with locations, and you can use the gateway and the service mesh to route accordingly. I've seen this pattern. It used to be some Spring technology I used a long time ago that used to do this as well. In general, I think more modern greenfield deployments don't use that pattern. They use config defined in YAML. So again, you're defining a mapping in the API gateway world, a mapping to a service. Typically, that config you're doing in YAML in Kubernetes CRDs, because that's the same for all your Kubernetes config. It can be deployed using GitOps, methodologies. keeps it nice and simple. And the service mesh, if you're running one, would handle the more detailed use cases and within your microservices. And again, you can commit typically the config for the service mesh into Kubernetes itself. So Kubernetes becomes the single source of truth, kind of like like it actually has etcd behind it, which is a key value store, which is kind of like the service locator, if you like. So Kubernetes and things like API gateways and service mesh provide their own typically behind the scenes. But yeah, you totally can integrate. We've got customers that do have service locators, do have registries, and we can hook up to them and dynamically update routes if that is so required.
Thank you, Daniel. It's a pleasure to listen to you. And of course, it's lots of information. So thank you for participating in this event. Thank you for supporting Ukraine. We really need it. And due to you, we have lots more charitable contributors. So thank you very much.
Thank you for the invite. Appreciate it. Great cause.